Hello, thank you all for joining today. The title is Assessing Building Performance in Terms of GHG Emissions and Energy Use. Then a brief introduction. Buildings have the high level of energy consumption which depends on significant factors, like more time spent indoor, which all experienced in recent pandemic. Left-sided graphs show a notable contribution of buildings in the energy usage and GHG emissions in Canada. And among all the states, Ontario is the second largest energy consumer, out of which 34% of energy usage and 22% of GHG emissions are by buildings. But unfortunately, most of our buildings do not have an efficient and sustainable function. Accordingly, Canada is committed to reduce 30% of GHG emissions by 2030. So to be track on this commitment, we should tackle with the lack of energy efficiency and sustainability by new studies to reach an optimized performance. Then finally, we can reduce energy use and GHG emissions and increase comfort in our buildings. So we are following three objectives. First of all, we assessing connections between our attributes, then suggesting a prediction model of GHG emissions based on EUI and other significant factors, and then carry out a comparison between EUI and GHG emissions of identical buildings before and during pandemic. My peers will provide you with a deep insight about our methods and dataset we are going to use.
For achieving the first objective that assesses the connection between the attributes which have been chosen for this part, since they are numerical and target is identifying the correlation between them, Pearson technique can be a good choice for this section. For finding a better choice between two labels that are available in the dataset, GHG emission and EUI, correlation can be identified. For gaining the second objective, the attributes should be classified at first, which can be achieved by the clustering algorithm. It's unsupervised learning that categorizes predictions by separating the factors and criteria in different groups. The members of each group are as similar as possible. By using this method, the dataset is ready for predicting the pattern by using a classification model.
The goal of this objective is to identify GHG emission label for target buildings. Since decision tree is more precise and suitable for prediction, and it is highly recommended for categorical data, after converting each attribute to different categories and splitting the attributes at each node based on the least amount of entropy, a pattern can be predicted for target buildings labels based on GHG. The final objective is about comparing identical buildings in two different timelines. The first selected technique is KNN algorithm. This technique was selected because of the fact that it is used to predict the class of unlabeled records and can work with categorical data. The other suggested technique is to apply the achieved pattern from decision tree of previous objective on unlabeled buildings to find their labels.
Let me talk about our dataset. It's the annual report of buildings in Ontario about energy and water consumption performance based on 2019 and mid of 2020 during the pandemic, with overall 3,093 records. But the reason we chose this dataset is mostly for energy intensity and weather normalized attributes. On the right, you can see some important attributes. To visualize better the data, scrubbing and reduction has been done. As you see the result of reduction on the left and the final dataset after cleansing here. Our target is energy consumption intensity and GHG emission. Based on our understanding of data set, rather than those important cities or building types, analysis shows a stronger correlation between the GHG emission and electricity use than natural gas use. Also, this chart shows a similar behavior in most of cities in terms of GHG average emission and indicates the more retail store and offices some cities have, usually higher average of GHG emission will be there. At the end, you see the energy use intensity in different cities based on building types. Now, with this knowledge, our future steps are finalizing data, applying suggested model, and analyzing, and at the end, evaluating. So, if the result was useful according to our objectives, provide solutions. All told, we know how energy consumption matters both to our environment and our economy. Thanks for listening to us.